Let's look at an example of a least squares regression line. We'll see what the equation tells us, and we'll also use the equation to make what is called a prediction. So this least squares regression line is about a particular car and its age X in years and its resale price Y in thousands of dollars. Now we all know that as time goes on, as X increases, the value of a car tends to go down. And we can see that this regression line equation actually has a negative slope. And that's expected for a car's resale price. So this first one says, what is the value of the correlation coefficient R? Would it be positive or negative? Well, if you remember from the past, R values are positive when the slope is positive, and they're negative when the slope is negative. So R is negative. Because the slope, M, is negative. Now, what does that tell us in the context of the data? Well, as the age X of the particular car increases, the resale price Y of the car tends to decrease. Now, what would be the resale price prediction for a car that is 3 years old? So for this, we want to start off with the original equation. Y hat of X equals negative 2.15X plus 13.57. And we want to plug in the value of 3. So find Y hat of 3. Let X equal 3. Alright, so we want Y hat of 3 equals negative 2.15 times 3 plus 13.57. Okay, I get 7.12. But keep in mind that this is in thousands of dollars. So it's $7,120. Alright, that's a prediction using the least squares line. Let's do one more. Predict what the price would be after 4 years. So let's see if it goes up or down. This time I get $4,970. So it did go down, as expected. Okay, what is the value of the slope of the least squares line? Negative 2.15, but what does it mean in the context of the problem? So, slopes can be defined as a rise over a run. But our number doesn't have, it's not in the form of a fraction. Or is it? It's just negative 2.15, right? So what we want to do is we want to put that over the right number that you would put here. And when a number is alone like that, negative 2.15, you could put it over 1. So that should make it clear how we want to say the meaning of this slope. Let the 2.15 be the rise, okay, and let the 1 be the run. And now let's just describe it in words. Okay, so for each year that passes, this is the run I'm talking about here, the resale price of this particular type of car tends to decrease by $2,150. Notice I said tends to because we don't know that it will hold true for all cars. Okay, even of this particular type. We just know that that is the trend that is predicted by the regression equation. Okay, then lastly, what is the intercept, the y-intercept here? The value in the equation that is in that spot is 13.57. But what does it mean in the context of the problem? Well, the intercept is often thought of as an initial value. Okay, so if that's the case, then let's say at time 0, after no time has passed, let's say when the particular car was just made, oops, its resale value or resale price tends to be $13,570. Okay, so the vehicle starts out being worth $13,570 as a resale value. Over time, it loses $2,150 a year. So, by the time we get to 3 years later, it will be only worth $7,120 as a resale value. And after 4 years after it was manufactured, it would be worth $4,970.